Have you ever wondered how a turboprop jet engine works? Well, you're not alone. Turboprop engines are an amazing feat of engineering, powering a wide variety of aircraft around the world. To put it simply, a turboprop engine is a type of turbine engine that drives an aircraft propeller. This combination of jet propulsion with the mechanical action of a propeller makes turboprops unique in the aviation industry. They are praised for their efficiency and reliability, especially in short to medium-range flights, and are a common sight in both commercial and military aviation. In the upcoming scenes, we'll dive deeper into the core of these engines, the crucial role of the propeller, and the factors that contribute to their impressive efficiency. We'll break down the complexity of these engines into smaller, digestible parts, making it easy for anyone to understand. So, buckle up as we take a journey to understand the mechanics of a turboprop engine. The heart of a turboprop engine lies in its core. Now, let's delve deeper and explore this core. It's made up of three main components: the compressor, burner, and turbine. These three work in unison to create the magic we know as flight. First, the compressor. It's like a big, powerful fan drawing in air from the outside, but it doesn't just let the air pass through. No, it squeezes it, increasing its pressure and temperature. This compressed air is then ready for the next stage. Enter the burner. Here, the high-pressure air meets fuel. It's a volatile meeting, and it results in ignition. The air-fuel mixture ignites, creating a hot, high-pressure gas. It's the kind of combustion that powers our flights. And finally, the turbine. This is where the burning gas expands and is put to work. It drives the compressor and propels the gas out of the engine. Once ignited, the burning gas expands and is forced out of the engine, providing the necessary thrust. But what about the propeller? What role does it play in a turboprop engine? The propeller, my friends, is the unsung hero of the turboprop engine. It's the bridge between the raw power of the turbine and the swift motion of the aircraft. At the heart of this operation is the turbine's shaft, intimately connected to the propeller. Now imagine the turbine's shaft as a relay runner. It takes the baton of energy from the turbine and sprints towards the propeller. This energy, the baton, is what causes the propeller to spin. It's a beautiful dance of mechanics and physics, a testament to human ingenuity. As the propeller spins, it slices through the air, creating a backward force. This force, known as thrust, propels the aircraft forward. It's like the push you feel when you ride a bicycle. So you see, the propeller plays a pivotal role in harnessing the turbine's power. Ever wondered why turboprop engines are so popular in aviation? One word: efficiency. These engines really shine at slower speeds, especially when compared to their pure jet counterparts. Let's unpack that a bit. Pure jet engines, while powerful, tend to guzzle up fuel at an alarming rate when they're not cruising at high altitudes and high speeds. Turboprop engines, on the other hand, sip rather than gulp their fuel. This makes them particularly economical for flights that don't reach the altitudes and speeds where jet engines perform best. Now imagine a regional flight. You're not going too far, not reaching extreme altitudes, certainly not breaking any speed records. This is where the turboprop engine comes into its own. It's like the efficient little engine that could, providing reliable, economical power for these shorter, slower flights, where a jet engine's strengths just aren't necessary. In this context, the turboprop engine isn't just the more fuel-efficient option, it's also the more reliable one. And reliability, as any aviator will tell you, is paramount. The result? A flight that's not only cost-effective, but also dependable. It's no surprise, then, that when it comes to regional and short-distance flights, turboprop engines are often the engine of choice. That's why turboprop engines are the go-to choice for many regional and short-distance flights. Let's quickly recap the amazing journey of air in a turboprop engine. We've journeyed from the stage of air intake, where our air molecules began their incredible voyage. They rushed into the engine, greeted by the compressor, their first stop in this mechanical wonderland. Here, they were squeezed together, their potential energy increasing with every moment. Then, they met with fuel in the combustion chamber, igniting a fiery dance that dramatically increased their energy. This combustion process pushed them out, creating a forceful thrust. But that wasn't the end of their journey. No, indeed, they had a rather important date with the turbine. The turbine, like an experienced maestro, took this high-energy exhaust and used it to power the compressor and the propeller. Speaking of the propeller, it played a pivotal role in this process. It sliced into the air like a hot knife through butter, generating the majority of the thrust that propels the aircraft forward. What's truly remarkable is the efficiency of this process. Turboprop engines, with their unique blend of jet and propeller technologies, deliver impressive fuel economy, especially at lower speeds and altitudes, making them the engine of choice for many regional flights. So, the next time you board a regional flight, you'll know the magic that's happening under the wings, thanks to the turboprop engine.